है ना?
Yes, sir.
चलो ठीक है. So basically we are studying about induction motor drives, right? And hopefully now everybody who have listened to me about this induction motor drives, they know that in the electric drives, your prime mover is an main component, right? And we use electric motors as a prime mover in these drives. So when we use induction motor as a prime mover in any of the electric drive, we call that drive as induction motor drive, right? What are the specific features of this induction motor drive or induction motor is? It have, if we talk about the polyphase induction motor, right, we can have two kind of induction motors. One is the single phase and other is the polyphase. Polyphase means three phase. Obviously poly means the three, multiple, three phase induction motor. So induction polyphase induction motor have the following features. We talk about the features of this motor, right? That it is self-starting. It is self-starting motor, right? And if we talk about the type of these polyphase induction motors, we have two types of polyphase induction motors, right? What are those types? Huh? Anyone from the class? What are the
Cage
right? Squirrel
and
cage
wound rotor.
and wound rotor. Very good. Squirrel cage and wound rotor. These are the two types of the polyphase induction motor, right? In the squirrel cage, uh, what we have is the rotor that looks like a squirrel cage if we remove the rotor core, right? If we exclude the rotor core, the circuit will look like a cage, right? So in case of squirrel cage, we know that your rotor have the conductors on the outer surface. I have shown the even the figure to you. How does it look like actually? So basically, we have learned that it will have the bars on the outer surface of the rotor core, right? It will have the bars on the outer surface of the rotor core, and these bars will be short circuited at the end rings, right? These will be short circuited by the end rings. So because of these end rings, what will happen? You will not be having any option to add on the external resistance. But because of this, your squirrel cage type motor will not be requiring any much maintenance, and it will also be a cheaper one, right? As in case of wound rotor, although we have a provision, we can add on the external resistance, right? How? By connecting the rotor windings, by adding the resistance to the rotor winding, by connecting them to the external circuit, right? If these are the windings, in this we have distributed windings, right? These distributed windings are being brought back for the connection to the outer world through the slip ring and brush assembly, right? These are the brushes and these are the slip rings. Now, because of this slip ring and brush assembly, we can add on the external resistance. We can add on the resistance to this circuit, to this armature circuit or the rotor circuit. But this makes this machine, which machine? Wound rotor machine, a costlier machine. And because of this brushes and slip ring assembly, it requires frequent maintenance. So we can conclude that your squirrel cage type motor will be cheaper and rugged and will also be requiring lesser maintenance, right? That's why you will find in most of the cases you will find that people are using the squirrel cage induction motor, right? They are not using this wound rotor induction motor. They are being using the squirrel cage type induction motor. Although both motors will have the self-starting capability, means once you will plug on it to the supply, it will start rotating. I think it's very clear. Is it very clear?
Yes, sir.
We also know now why do we call them as induction motors? I think everybody can answer to this. If someone asks from in a voice ki why do we call these motors as induction motors? So I think everybody from this class can answer this question. Raise your hand who wants to answer it for this class. Only 3? Oh my god. Still, I think there is a doubt. Okay, let us give a chance to Vihan Mishra. Vihan, why do we call these motors as induction motors?
Sir, because we give the supply to stator windings and the magnetic field produced by them induces a EMF in the rotor conductors, which leads to
right. Very good, very right. Basically, you can shortcut this answer by saying that because in these motors your rotor receives the energy from the stator by the means of induction, right? There is no direct or connection of the supply to the rotor winding. That's why we call it as induction motor, right? Is this clear, bachcho?
Yes, sir.
Because your rotor receives the energy from the stator by means of induction, right? So the energy transfer takes place by the means of induction between the stator winding and the rotor winding, right? Or stator circuit and rotor circuit. Okay, so that's why we call it as induction motor. Now one more answer can be asked, one more question can be asked in the Viva voice, that why we call it as singly excited machine. Who will answer to this? Singly excited machine, why we call it as singly excited? Because Gitansh.
Yes sir, because sir हम energize सिर्फ stator को करते हैं इसमें.
Right, because we directly connect the stator windings to the supply, right? Whereas your rotor windings are not connected to any supply. They will be getting the energy from the stator winding. So basically, because we are energizing or exciting the stator winding only, that's why we call it a singly excited machine. क्योंकि एक सर्किट को एक्साइट कर रहे हैं, दो सर्किट हैं, एक स्टेटर पे और दूसरा रोटर पे. हम क्या कर रहे हैं, केवल स्टेटर सर्किट को ही सप्लाई दे रहे हैं. That's why we call it as singly excited machine. One more question can be asked, that why we call it as asynchronous motor. Who will answer to this? Shweta? Okay, Shweta, you answer it.
Sir, we call it asynchronous motor as the rotor does not rotate at a synchronous speed.
Yeah, right. Basically, we call it as asynchronous motor because your motor doesn't have capability to rotate at synchronous speed, right? It cannot operate at a synchronous speed. Your induction motor cannot operate at a synchronous speed. That's why we call it as asynchronous motor. Now question will arise, why there will not be any torque? Why there will not be any torque or force, means why it cannot operate at a synchronous speed? Why? Question could be, why your induction motor cannot operate at a synchronous speed? I think, let me have an answer from you. Let me see who has raised the hand. Very few people. Saurabh.
सर अगर सिंक्रोनस स्पीड पे होगी तो रिलेटिव स्पीड 0 हो जाएगी और उससे फ्लक्स कटिंग एक्शन नहीं होगा तो टॉर्क जनरेट नहीं होगी.
Right. Basically, it is only because of the flux cutting action that your EMF is induced in the rotor conductors, right? If we see it to be the rotor circuit where we have the rotor conductors, then in these rotor conductors an EMF is produced because of this flux that rotates in the air gap, right? It is because of the flux that rotates in the air gap with a synchronous speed, right? And if your rotor also starts rotating at a synchronous speed, the relative speed between the magnetic field, rotating magnetic field, and the conductor becomes 0. So there will not be any flux cutting action happening to these conductors which are placed over the rotor. That's why if there will not be any flux cutting action, then Faraday's law will say that there will not be any EMF that will be induced over this circuit. That means your E2, that is the EMF induced on the rotor, will be 0. Once your EMF will be 0, although your rotor conductors is complete, means path of the conductors is complete, but because EMF is 0, the current flowing over there will be 0. And when this current will be zero, although it is being placed in a magnetic field that is being produced by the stator winding, this rotor is not going to experience any force, right? It will not be able to generate any torque because of which it is rotating, right? So because of this reason, this motor cannot be able to operate at a synchronous speed. It will always be operating a speed lesser than or equal or greater than the synchronous speed, right? For the motoring action, it will always be lesser than the synchronous speed. Is this clear, bachcho?
Yes.
Okay, fine. So these could be some of the answers which someone may ask if you have studied the induction motor drives, right? Or induction motors, in fact. Any other question which may come to your mind? I think it's very clear now to the students what does induction motor means, how does it operates, right? Why do we call them as asynchronous motor? Let us move ahead. See, we already have studied the equivalent circuits, that is per phase equivalent circuits of the induction motor, right? Per phase equivalent circuit. We already have studied that how do we develop this per phase equivalent circuit. Obviously, why do we develop it? Basically, to analyze this behavior of the machine, we require the equivalent circuits, right? Because we want to have the electrical behavior, that's why we will be developing the electrical equivalent circuit, right? If someone is interested in mechanical behavior, then he will be developing a mechanical equivalent circuit, right? And in these cases, or in this course, we are interested in knowing the electrical behavior of induction motor. So what we'll be doing, we will be using the electrical equivalent circuit of the induction motor, right? That is a per phase equivalent circuit. As your motor is a 3-phase motor, but what we'll be using the per phase equivalent circuit. The variables which we'll be getting, we'll be multiplying it by the 3 wherever it is applicable, right? So if you remember, as we even have discussed that we will have the winding on the stator side as well as on the rotor side, right? As well as on the rotor side. Winding means a coil, right? Coil means a combination of R and L. I think it's very clear. A coil means a combination of R and L. R connected in series to L. That forms the winding or the coil, right? So that means we will have a resistance that is being representing the stator resistance and the stator reactance axis, right? Now see, your power from the rotor, from the stator is transferred to the rotor by the means of induction, right? By the means of mutual induction. So to represent that, what we do, we use this imaginary winding. This basically represents the power transfer process from the stator to the rotor. Also, because your rotor and stator winding, they are not electrically connected, but for this case, we have electrically connected them. That means we had to take those things in account which may affect this connection. And the major thing is the number of turns in the stator and the rotor windings, right? So because of the turns, number of turns, the effect may have been varying. That's why what we do, what we are doing or what we are writing is that suppose this is the value XR dash and this is RR dash by S. What this dash represents? Dash represent means they are the values referred to the particular side. And in this case, what we had done is we had referred the rotor values to the stator side, right? We have referred the values from the rotor side to the stator side. So these are basically stator side referred rotor values, right? That's why we call it as per phase equivalent circuit referred to stator side, okay? So this will be XN. Okay, I think I already have told you that why do we attach this S with this resistance, although your resistance actually do not varies with the frequency, right? See, have I told you नो, यस और नो? मैंने बताया कि ये S जो है रेजिस्टेंस के साथ क्यों अटैच कर दिया हमने रिएक्टेंस की बजाय, बताया क्या?
नो सर।
देखो, अगर हम रोटर सर्किट की बात करें, रोटर सर्किट का मतलब ये हो गया कि रोटर कॉइल का मतलब उसमें एक इंडक्टर होगा और एक रेजिस्टेंस होगा. दैट विल बी दी components that will be in the rotor side winding, right? Agar if at the starting, right, at the starting means without any slip, at the starting slip will be 1, right? So without any slip, the EMF induced is E2, EMF induced on rotor circuit, let it be E2, right? Circuit is E2. Now tell me, at any slip S, what will be the EMF induced? At any slip S, what will be the value of EMF induced? It will be equals to S time of E2. Yes or no?
Yes sir.
It will be S time of E2. अगर E2 जो है वो EMF है जो इंड्यूस होता है जब रोटर रुका हुआ है, तो जब रोटर घूमने लगेगा तो कोई स्लिप जनरेट होगी. स्लिप का मतलब समझ में आ रहा है ना? स्लिप इज द रिलेटिव डिफरेंस बिटवीन NS एंड NR. स्लिप इज डिफाइंड एज NS minus NR over NS. So mathematically we define the slip like this way. तो अगर जब रोटर रुका हुआ है उस समय में जो EMF इंड्यूस हो रही है रोटर कंडक्टर्स में, यदि वो E2 है, तो जब वो रोटर रोटेट करने लगेगा तो उसके अंदर EMF ऑब्वियसली कम होने लगेगी, है ना, क्योंकि फ्लक्स कटिंग एक्शन कम होने लगेगा, तो वो स्लिप के बेसिस पे होगा चेंज. तो दैट मींस एट एनी स्लिप S द EMF विल बी SE2. तो अगर मैं किसी स्लिप S की बात करूं तो उस समय पे जो अप्लाइड EMF होगा, जनरेटेड EMF होगा, इट विल बी SE2, राइट? सिमिलरली जैसे ये EMF SE2 होगा, व्हाट विल बी अबाउट रिएक्टेंस X2? अगर स्टैंड स्टिल कंडीशन में, इफ एट स्टैंड स्टिल the reactance X2, the reactance of the rotor circuit was X2, right? If at a standstill the reactance of rotor circuit is X2, right? That means it will be equals to 2 pi F2 L2. Will it be? Where F2 will be equals to F1 at the standstill. So at any slip S, what will be the value of this? At any slip S, the value of X2 will be, how much it will be? It will be 2 pi SF2 or SF1. F2 is SF1 into L2. So we can write it as S time of 2 pi F1 L2. And this 2 pi F1 L2 is nothing but it is X2, because at the time of standstill your F2 will be equals to F1. F2 is the rotor side frequency, F1 is the stator side frequency, right? So at any slip S, your reactance becomes S time of X2, right? Your EMF becomes S time of E2. So this will be the exact equivalent circuit, right? Now, because of this SE2, there will be a current flow that we can write as I2. What will be the value of I2 for this circuit? What will be the value of I2? Who will tell to me? Raise your hand. What will be the value of I2? Okay. Who has raised the hand? Deepak. Okay, Deepak, batao beta. What will be the value of I2 for this case?
सर SE2 हो जाएगा सर अपॉन,
राइट
सर अपॉन अंडर रूट R2 का स्क्वायर प्लस S.
देखो, I2 will be equals to V by Z or
Yes,
V2 by Z2, right? I2 will be equals to V2 by Z2 for this circuit, right? Here V2 is what? It is S time of E2, right? This is the V2. How much is the Z2? Z2 is R2. Z2 is R2 plus J times of SX2. Right? This will be the value of I2. Yes or no? Yes or no, bachcho?
Yes, sir.
This
Yes,
can be
sir.
written. This can be written as E2 over R2 by S plus J times of X2. Can you write this?
Yes, sir.
Right? Taking S to be common. So because why we had done this? Why we have taken S to be common? Because of this, we'll need not to have the effect. We need not to consider the effect over the two variables, right? As was the case, right? If we do so, now we have to consider the effect over the one, right? Although actually it will not be happening, right? There will be an effect over X2 and E2 of this slip. But to have an equivalent values and in the simplified way, we have considered that your resistance will be affected by this value of slip. And that is the case. You can see over here how they have made this equivalent circuit. They have made this equivalent circuit like this way, that there will be a value of reactance X2 and a resistance R2 by S. So you could have seen in many books this as a rotor equivalent circuit, where they have represented the resistance as R2 by S. Okay, and same is the case over here. Did you get now why they have used this R2 by S instead of R2, and instead of S XR they have used XR? So did you get this thing?
Yes, sir.
Yes, sir.
Right? Let us come back. Let us come back and you just see we have the equivalent circuit, right? You have already studied this equivalent circuit, and let us start from here. Suppose this is the equivalent circuit of the polyphase. This is the per phase equivalent circuit of a polyphase induction motor, right? Now we can get an approximate equivalent circuit if we shift this branch to this side, to leftmost side, because V is the applied voltage, right? So there will be a small error if we shift this XM to this side, right? But there will be a large simplification. So that we call as approximate equivalent circuit. Approximate equivalent circuit. क्या होगा भाई approximate equivalent circuit को जरा सबके सब बना के देखो. मैं कह रहा हूं कि what we had done is we had shifted the shunt branch, this XM branch, to this side, right? We are applying the voltage over here, that is the V. Let V is the applied voltage. Okay, this is RS, this is XS, means the rotor resistance, stator resistance, stator reactance. This is rotor reactance referred to stator side. This is rotor resistance referred to stator side, right? This is rotor reactance referred to stator side. This is rotor resistance referred to stator side. Now the current that will be flowing over here will be counted as the rotor current, IR, right? That will be flowing in this branch will be counted as rotor current, and the current that will be flowing in this XM will be counted as magnetizing current, right? Where the IM will be the magnetizing current, right? And IR dash will be the rotor current. Okay. So can you get the value of rotor current? Can you get the value of rotor current for this equivalent circuit? Yes or no? Can we get the value of this rotor current? Yes or no?
Yes, sir.
Yes, sir.
Again, because these two are in parallel, means these two branches, one, if we take this to be one branch and this to be the second, you can see that both are in parallel, right? And both are being connected to the supply voltage V. So obviously the current that will be flowing in this branch can be calculated as, and that is the current IR, right? That can be counted or calculated as the voltage applied across that branch divided by the impedance of that branch, right? How much is the impedance? It is Rs plus Rr dash by S plus J times Xs, that is the stator side reactance, plus rotor side reactance referred to stator side. So this will be the value. Yes or no?
Yes, sir.
So this will be the current that will be flowing in the rotor circuit, right? Now, let us calculate the power that is called as air gap power. What is air gap power? Air gap power is that power that is being transferred from the stator to the rotor via air gap, right? There is an air gap between the stator and the rotor, right? There is the air gap between the stator and the rotor, and in that air gap your flux is rotating, right? So basically power is being transferred through this air gap from the stator to the rotor circuit. So the power that is being transferred through this air gap is called as air gap power, which generally denoted by PG. Obviously this will be the power that will be received by the rotor circuit, right? So if this is the rotor circuit, which we have learned that your rotor circuit will be having a reactance X2 and a resistance R2 by S if EMF E2 is being applied. Because of this E2 there will be a current IR. So the power that will be consumed, or that will be transferred in fact to the rotor circuit, will be equals to IR square into R2 by S, right? This will be the per phase power. Because you are considering a 3-phase machine, you can write it as 3 times into IR dash square into RR by S. Once this IR dash is being referred to that side, right? They all are being referred to that side. Okay, so this will be the air gap power. Okay, if we replace, or this is the air gap power, means this is the total power that is being received by the rotor circuit. This is the total power that is being received by the rotor circuit. Now we know that in case of induction motors or in case of any electrical machine, there are 2 kind of losses, right? One we call as core loss, another we call as copper loss, right? Your core loss are fixed losses and they depends upon the frequency, right? Your core loss, keep it in mind what I am saying, your core loss are fixed loss. Do you agree? Core loss are fixed losses. In case of electrical machines, you could have studied that there are 2 kind of losses, right? The one we call as fixed loss and other we call as variable loss, right? Which are the fixed loss? Raise your hand. Which are the fixed loss? Which losses are to be called as fixed loss? Only Akshay knows this. Huh? Okay, Akshay, you tell me. Huh?
The core losses.
Right. Basically, in case of electrical machines, you could have studied that losses can be divided into 2 parts. One called as the constant or fixed loss, right? Other called as variable loss. Why do we call the other losses as variable loss? Because they are dependent upon the load. Your variable loss are dependent upon the load, whereas they are independent to the load. Means whatever will be the load, they will remain constant, whereas these variable losses are dependent upon the load. So in case of motor, load means they will be dependent upon the current that motor will be taking, right? So variable losses are basically the copper loss, which we also call as I square R loss. So these losses basically depends upon this I, value of I, which depends upon the load, right? If you put a more load, the current drawn by the supply by the motor will be more, right? That's why these losses will be variable loss. Although contrary to this, the core losses are the fixed losses, right? They hardly depend upon the load, but these core losses, they depends upon the frequency. Yes or no?
Yes, sir.
Because they are core losses are comprises of eddy current and hysteresis loss, right? Core loss are comprises of eddy current and hysteresis loss, and both depends upon the frequency. In fact, one depends upon the frequency, square of the frequency, right? So because they depends upon the frequency, in case of rotor circuit, what is happening? This core loss will be a dominant loss. Sorry, these copper losses will be the dominant losses, whereas core loss will be negligible. Why? Simple reason is because once your motor is rotating at full load speed, that will be the speed near to the synchronous speed, the rotor frequency will be very, very small. As we know that your rotor frequency F2 is equals to S time of F1. If we consider even that your machine is a 50 hertz machine, right, and it is being rotating at a nearby of the synchronous speed, so the slip value will be very, very small. The slip value will be small because slip decreases as your speed increases. ये बात तो क्लियर है ना, स्लिप की वैल्यू घटेगी जैसे जैसे स्पीड बढ़ेगी. क्यों? क्योंकि स्लिप जो है वो ns माइनस nr ओवर ns है. अगर रोटर रुका हुआ है, दैट मींस रोटर की वैल्यू 0 है, तो स्लिप की वैल्यू कितनी होगी? अगर रोटर की वैल्यू 0 है, इफ nr इज 0, तो स्लिप विल बी 1. लेकिन यदि स्लिप अगर nr जो है आपका ns स्पीड से ही घूमने लगे, तो स्लिप की वैल्यू कितनी हो जाएगी? 0. दैट मीन्स जैसे जैसे स्पीड बढ़ेगी वैसे वैसे स्लिप की वैल्यू 0 की तरफ घटेगी. इज दिस क्लियर?
यस सर.
तो अगर मोटर आपकी सिंक्रोनस स्पीड के आसपास घूम रही है ना, इसका मतलब ये है कि उसकी जो स्लिप की वैल्यू बहुत कम है. और यही मानते हुए कि भाई स्लिप की वैल्यू बहुत कम होगी, इसलिए रोटर फ्रीक्वेंसी उस केस में बहुत कम होगी, क्योंकि रोटर फ्रीक्वेंसी इज एस टाइम ऑफ द स्टेटर फ्रीक्वेंसी. तो अगर स्टेटर फ्रीक्वेंसी 50 हर्ट्ज थी, तो रोटर फ्रीक्वेंसी बहुत कम हो जाएगी, है ना. और क्योंकि रोटर फ्रीक्वेंसी कम हो जाएगी, दैट्स व्हाई दीज लॉसेस, कोर लॉसेस, कैन बी नेग्लेक्टेड, राइट. सो रोटर कोर लॉस आर बेसिकली नेग्लेक्टेड एंड ओनली द डोमिनेंट लॉस व्हिच आर द रोटर कॉपर लॉस, दे आर सब्ट्रैक्टेड फ्रॉम दिस एयर गैप टू कैलकुलेट द मैकेनिकल पावर डेवलप्ड, राइट. बात को समझ में आई? हमने क्या किया कि ये जो पावर है ये मिली है रोटर को. अब रोटर क्या करेंगे, हमें इस पावर में से लॉसेस घटाने होंगे ये देखने के लिए कि कितनी पावर बचेगी मैकेनिकल एनर्जी में कन्वर्ट करने के लिए, राइट. सो व्हाट वी आर डूइंग, वी आर फर्स्ट कैलकुलेटिंग द रोटर कॉपर लॉसेस. कोर लॉसेस को हम नेग्लिजिबल मान रहे हैं क्योंकि फ्रीक्वेंसी बहुत कम होगी, इसलिए कोर लॉसेस नेग्लिजिबल होंगे. लेकिन कॉपर लॉसेस कितने होंगे? दे विल बी इक्वल टू 3 टाइम्स ऑफ IR डैश स्क्वायर इनटू RR. दिस विल बी द रोटर कॉपर लॉसेस. If we subtract this loss from this one, we'll get the mechanical power developed. That will be the mechanical power developed, right? So this will be 3 times of how much it will be then? This
IR square. 3 times IR square.
It will be PG minus PCU, and that will be equals to 3 times of IR dash square into RR dash 1 minus S over S.
Yes, sir.
Right. So this will be the mechanical power developed. If this is the PM, can we get the value of torque generated? Yes, because we know that PM is equals to Tm into omega, where Tm is the mechanical torque or the torque, basically torque generated by the motor, T into omega, where P is equals to T into omega. Yes or no? Yes or no? That means T is equals to P by omega. Bolo?
Yes, sir.
So can we write this as T torque will be equals to PM divided by omega M?
Yes, sir.
Also, this PM and PG, they have relation. If you drive, you can get the relation, right? And that is equals to 1 minus S of PG. Similarly, your omega M, that will be the mechanical speed, and the synchronous speed, they will have a relation that it will be equals to 1 minus S of omega S. So we can write that this torque can also be calculated as PG by omega S by this ratio. We just have calculated that PG is nothing but it is 3 times of IR dash square into RR dash by S, right? If we divide it by omega S, then we can have the value of torque. So this will be the value of the torque. This will be the expression for the torque, right? So the expression of the torque, if we replace this IR by the first value which we have derived for this IR, if we replace by this, how much will be the value of what will be the expression for the torque? It will be 3 of omega S into IR square की वैल्यू रखेंगे तो it will be V square. अगर मैग्नीट्यूड की बात है तो it will be RS plus RR dash by S का स्क्वायर प्लस XS plus XR dash का स्क्वायर into RR dash by S. This will be the expression, yes or no? This is the final expression for the torque. And from this torque, you can plot.
सर
हाँ बोलिए.
डिनोमिनेटर में स्क्वायर गलत नहीं हो रहा?
क्यों?
सर हम लोग IR को स्क्वायर कर रहे हैं तो फिर ये प्लस के बाद
देखो मेरी बात सुनो. जो मैग्नीट्यूड है, अगर z जो है z x plus jy है, तो मैग्नीट्यूड जो होगा इट विल बी अंडर रूट ऑफ x स्क्वायर प्लस y स्क्वायर.
सर मैग्नीट्यूड बोल रहा था,
है ना? तो इसका मैग्नीट्यूड लिया, ये रूट हट गया और खाली
स्क्वायर मैग्नीट्यूड बोल गया. हां ओके सर,
कोई बात नहीं, है ना? ठीक है, और आगे बढ़ते हैं. तो दिस विल बी द फाइनल एक्सप्रेशन फॉर द टॉर्क. एंड फ्रॉम दिस टॉर्क you can plot a characteristic between this slip S and this torque, right? If you plot a characteristic, you will get a characteristic like this one, which we call as torque speed or torque slip characteristic. If you put torque over here and speed over here, and if your speed is 0 over here, ns over here, you will get a graph like this for this expression. Right? You will get a graph like this. Okay? When NR is 0, you can see that there is a positive torque that motor will develop, and we call this torque as TST. That is the starting torque. We call it as starting torque. And at the starting torque, basically your slip value will be how much? At the time of starting, 1. Slip will be 1 over here, whereas at synchronous speed it will be 0. Right? So it will be reciprocal to speed. This torque is called as the maximum torque or breakdown torque. We call it as TM or TB. Right? So TM is maximum torque. The slip at which it occurs, we call it as slip at which maximum torque occurs, right? And generally denoted by SM. Is this fine?
Yes, sir.
So this will be the characteristic which you will get from this expression. See, this torque, this expression can be differentiated with respect to S, right? And can be equated to 0. So if we differentiate this expression and we equate it to 0, we'll get the value of that slip at which the torque will be maximum, right? The value of that slip will be equals to, if we do so, we will get an expression that it will be equals to plus minus RR dash divided by the value RS square plus XS plus XR dash ka square. Okay? And if you put this value of SM, you will get the value of maximum torque also. The expression of the maximum torque will be equals to 3 by 2 omega S into V square divided by RS plus minus under root of RS square plus XS plus XR dash ka square. This will be the value for the maximum torque, and this will be the value for the slip at which maximum torque occurs. This will be the two expressions, right? If you see this expression, you can see that the slip at which maximum torque will occur, it is directly proportional to the rotor resistance, right? What we can observe is the slip at which maximum torque occurs, it will be directly proportional to rotor resistance. इसका क्या मतलब हुआ? इसका मतलब ये हुआ कि अगर किसी मोटर का रेजिस्टेंस R1 था जिसपे ये कैरेक्टरिस्टिक थी, यदि मैं रोटर रेजिस्टेंस बढ़ा दूं, if I add on some more resistance to that circuit, your characteristic will shift in this fashion. In which fashion? That maximum torque, the slip at which maximum torque is occurring, right? It will change. In fact, it will increase with the increase in rotor resistance R2. If R2 is greater than R1, then this will be the characteristic. Is this fine?
EM same होगा?
See this? This is the expression for the
अच्छा, okay, yes, sir.
See, this is the very good question, that whether the maximum torque will remain same even if we increase the resistance. The answer is yes, because there is no rotor resistance value or parameter that is being associated with the maximum torque, right? So your maximum torque of the machine will not going to change, but yes, this slip at which it will be occurring, it is going to change, right? And because of this, even the starting torque is going to change. Is this clear, bachcho? That is the reason why do we use the wound rotor machines, right? In the wound rotor machines, we have option to add on the external resistance. Now with that external resistance, we can increase or decrease the starting torque, right? There could be the applications where the starting torque may be the variable one, right? So in those applications, we will be going for wound rotor induction motor or slip ring induction motor, right? Is this clear, बच्चों?
Yes, sir.
फाइन. तो आज के लिए इतना ही है, फिर हम आगे क्लास में पढ़ेंगे.